All right, good afternoon or good evening to you, grade nines. I hope that you guys are all doing well. Just very quickly, guys, I will start the lesson as per normal just in a few minutes. We're going to get going with some new work today. We want to still continue with the world, going to add solving equations because I know that this is something that a lot of students still have a little bit of a tough time with. So we're going to be looking at how we solve equations, not so much um, how we deal with numbers, but rather the approach that we take when we try and solve equations, right? Working with the numbers themselves generally isn't so tricky, but sometimes when we're given really complicated equations to solve, a lot of students get thrown off because of the approach that you need to take to solving those equations. So we want to discuss three different things today: additive inverses, multiplicative inverses, and exponential equations. We're going to go through a few different examples, just try and break them down so that by the end of the lesson, we have sort of developed a really helpful approach that we can use so that no matter how complicated our equations get, we still have a solid approach that we can use. Okay, so I am going to get started quite soon. I just want to check. Um, we are using a slightly different setup today in comparison to normal. So I would like it if you guys could please just let me know if you can hear me clearly. It's quite important that you just type yes or no into the comment box for me, please. Just to let me know if you can hear what I'm saying clearly or if the audio quality isn't so great. I just appreciate a little bit of feedback from you guys. So please just type a message into the comment box for me, letting me know if you can hear me clearly. Um, then, guys, I'm just going to give everyone 1 or 2 minutes to quickly join us, and then we're going to get started with today's lesson. So I hope that you guys are ready for today's work. Um, Make sure that you have your calculator and all of your basic stationery, just like I'd usually ask you. And then we're going to get started quite soon. All right. I'm already going to start sharing my screen. But please just quickly let me know if you can hear me clearly. Just type a yes or a no into the comment box so that I have a rough idea of how the audio is. I'd really appreciate it, guys. Okay, guys, just on a side note, while I start with sharing my screen, I want to remind you guys that we are now live on two different platforms, right? This was not the case last week. This is something new, though, so I just wanted to bring it to your attention. We are live on Facebook just like we are every week. Nothing has really changed there, but we are now also live on YouTube. So I can see that there's also a few of you joining on YouTube, which is great to see. I'm going to assume that you guys can hear me clearly. I haven't seen any messages, but if you guys do have a problem with hearing me, you need to please just let me know. All right. Um, I'm going to quickly start sharing my screen with you guys so that we can get started. I don't want to take too much time waiting around for everybody to join us. They'll join us whenever they get an opportunity. But you guys should now be able to see my screen on your screen. And just like normal, I'm scribbling in different colored pens: white, yellow, orange, and green. So, if at any point during the lesson you cannot hear me or see what I'm writing, you really need to please let me know so that I can fix the issue. Um, so, if you guys can just keep me in the loop as far as all of that is concerned, I really would appreciate it. Okay. So it looks like you guys can see everything. So, like I said, I'm not going to take too much time or spend too much time waiting for everyone else. I know that you guys have got places to be. So I'm going to get going with today's work. Uh, Grade nines, over the last 2 weeks, guys, we've been discussing how we go about solving, or not solving, but simplifying algebraic expressions, right? We've covered all of the basics when it comes to monomials, binomials, and trinomials, and focused on the approach that we use to solve or simplify those expressions properly. Now, it's important that you guys understand that um, expressions and equations are two different things. All right? They are not the same. Just give me 1 second, please, guys. Okay, so I've just quickly gone and corrected one or two things for the audio, so you guys should be able to hear me. Please just make sure that you do also check your internet connections. If your internet isn't stable enough, it is going to give you a little bit of a hard time. Okay, and you won't be able to hear me as clearly as you'd like. So just please make sure that you double check that. So, guys, like I was saying, over the last 2 weeks, we've been discussing algebraic expressions. And today we sort of want to pivot and focus on something slightly different. We want to discuss solving algebraic equations. So you can go ahead and write down today's date, which is the 15th of April, and the heading is going to be solving algebraic equations. Now, let's just start at the very beginning. You guys should already understand the difference between equations and expressions. But in case you don't know, I'll quickly give you a rough explanation so that you guys are all on the same page as me. When we talk about an expression, grade nines, we are talking about a set of algebraic terms that usually can be simplified in some way, right? Whether that's collecting like and unlike terms, or we are factorizing in order to manipulate something so that we can better try and approach our simplifying. Factorizing and simplifying generally have to do with algebraic expressions. Now, in today's lesson, we want to focus on equations, which are slightly different, right? When we talk about an algebraic equation, we are now talking about two different algebraic expressions that are equal to one another, right? There is a difference between us using an equal sign at the beginning of our step to show our progress as we simplify something, to having an equal sign in between two different expressions, right? That is not the same thing. So you guys need to make sure that you are aware of that, because that is going to impact your understanding of today's work. Now, as far as algebraic equations are concerned, we need to understand a few things very quickly before we can dive into solving these different equations, right? So, this is actually something I still go through with grade sixes and grade sevens. We know that our four major operations, or our fundamental operations, are adding, subtracting, multiplying, and dividing, right? And we really must make sure that we are familiar with how these four operations interact with one another. So, if I add something, right? Let's say I have, for example, 6 plus 3, that would give me 9. If I wanted to reverse the effect of the plus 3, I would obviously subtract, right? So I take my answer, 9 minus 3, and I get back to my starting point. Now, it's no surprise that these operations have opposite effects, but we need to make sure that we are acutely aware of this in today's lesson, because addition and subtraction are what we call additive inverses. So the first thing we need to write down over here is that addition and subtraction are called additive inverses, right? They reverse the effect of one another. Now, the same thing is true for multiplication and division. If I take a specific number and I multiply it, let's say, for example, I have 5 times 8, that would give me 40. Now, if I wanted to reverse the effect of multiplying by 8, I would want to go ahead and divide by 8. So 40 divided by 8 would get me back to my starting point, or my starting value of positive 5. Right? So in the same way that our addition and subtraction operations are considered additive inverses, we also need to keep in mind that multiplication and division also have opposite effects, right? They have a tendency to cancel one another out, and these are called our multiplicative inverses. Now, when we go ahead and we start solving equations, guys, you have had your fair share of practice with solving equations, but you might not understand why certain things are done in the fashion that they are. And that's just what I want to quickly touch on at the beginning now of today's lesson, before we also go and take a look at exponential equations, right? So when we understand that these sets of operations have got inverse effects, if I'm given an equation like 2x plus 4 is equal to 12, how would I solve an equation like this? First things first, you must recognize that it's an equation, right? Because we have an equal sign in between two different expressions, no matter how complex or simple they might be. Now, if I wanted to solve this equation, we need to keep in mind that solving means that we are looking for the value of an unknown variable, right? So in this case, we would be looking for the value of x. If I want the value of x, it means I need to practice isolating the variable. So if I want to isolate x to get it on its own, I'm going to try and move everything else that I can around in the equation so that I have all the x's on their own and all of the constants on their own, right? So that would tell me that I want to get rid of this plus 4 on the left-hand side of the equation because I want x on its own. So in order to do that, I have to move this plus 4 over to the other side of the equation. Now, when we solve algebraic equations, this is where our additive and multiplicative inverses come into this discussion. If I want to get rid of the effect of this plus 4 on the left-hand side, what would I need to do? Well, I would need to subtract 4 on the left-hand side. But when we're working with an equation, we need to make sure that we do the same thing on the left-hand side and on the right-hand side of the equation. So on the left over here, we would have 2x. These two 4s, the minus 4 and the plus 4, are going to cancel one another out, leaving me with 12 minus 4 on the right-hand side. So when I simplify that, I'm going to get 2x is equal to 8, right? And this step uses what we referred to as earlier as our additive inverses. Now, when we get to this second step over here, 2x equals 8, you can see that we've already dealt with all of the adding and subtracting, and now all we have left to do is deal with addition multiplication and division. So we've got to keep in mind that we are trying to get x on its own. But right now we have this 2 attached to the x, which is making things a little bit frustrating. And keep in mind that 2x is the same as 2 times x, right? So to get rid of the effect of that 2 that's being multiplied by the x, we would use our multiplicative inverses. So if I divide by 2 to cancel its effect, I have to apply this division to everything else in the equation on both the left-hand side and the right-hand side. When this happens, the 2's cancel on the left-hand side, leaving us with just x, and 8 divided by 2 gives us a value of 4. Right? This is something that you guys should all be pretty comfortable with. You shouldn't see any of this as new work. And you obviously should also know by now, grade 9s, that I can take this x value back to the beginning and substitute it into x's place in order to check whether or not the left and right hand side of my equations are equal to one another. If they are equal, it means that you've solved the equation correctly. And if you haven't, it unsurprisingly means that the two values will be different on either side of the equation, right? So those are some of the fundamentals that we really need to understand when it comes to solving different equations. Now, later on in this example over here in the second step, we've used our multiplicative inverses. Now, when it comes to solving equations in tests and exams, it's much more difficult to try and apply this sort of process in this fashion because it ends up being quite time consuming, right? We want to try and save as much time as possible. So this is the longer method of how we would solve an equation, right? But we can take exactly the same equation, and I'm going to write it down on the right-hand side of the screen. If we have 2x plus 4 is equal to 12, there's a slightly faster way to think about what we're doing so that we can try and save time. If I know that I want to move this plus 4 over to the right-hand side of the equation so that I can isolate the variable and collect all of the constants together, this plus 4 can be moved over the equal sign, and without having to do minus 4 on the left and minus 4 on the right, this plus sign simply changes into a minus sign as we move it over the equal sign. Right? So now we're going to have 12 minus 4. And so when we go about it like this, we end up saving a little bit of time. And as we deal with more and more complex algebraic equations, it also minimizes the amount of mistakes or the number of mistakes that we are likely to make. Right? And then we again would divide on both sides to get the same answer as we did in the first variation of this example, right? We get x minus 4 in both cases. So as we go through equations in today's lesson, I'm going to be applying this concept. So I want you guys to make sure that you are in fact comfortable with it and that you understand how we use these additive and multiplicative inverses to our advantage, right? Now, with that being said, like I said at the beginning of this lesson, today is not so much about how we plus and minus values, but rather about understanding an approach that we can use when we go into examples where we need to solve equations. So I'm going to write down 2 more notes quickly. You must remember that solving involves finding the value of a variable. Right? Solving involves finding the value of a variable. And on top of that, when we have these complex equations that we need to work through, when we do simple equations or complicated equations, we always want to start by dealing with our additive inverses first. In other words, try and deal with adding and subtracting first. Right, we want to collect all of our like and unlike terms as we move things around the equation, and then worry about multiplication and division. Okay, so keep that in mind. Whenever we look at an equation, we obviously want to follow PEDMAS or BODMAS or BEDMAS, whichever acronym you guys prefer to use. But it's also important to keep in mind that you really want to get all of the adding and subtracting out of the way as early on as possible so that you can then deal with your multiplication and division. All right. So I'm going to give you guys a second to quickly copy this down if you want to, and then we are going to dive into some examples. Okay, so you've got 2 minutes to quickly copy down whatever you need to, and then we're going to look at some examples of solving algebraic equations. And like I said, guys, we will then also take a look at how we go about solving exponential equations. All right. Some of you might be familiar with the concept of logs, okay? Some of you might not. Now, logs is a concept that we use when we're solving exponential equations, but that is usually done at around grade 11 level, okay? So I'm not going to worry about logs for today. If you guys know how to use logs, that's awesome. And you can go ahead and use that in calculations if you come across questions like that in your work, but that is pretty unlikely. Okay, so let's go ahead and take a look at some examples. I am going to be going through a few different algebraic equations. And remember, when we go through equations, the goal is for us to solve for the value of the variable. There's also a specific kind of question involving square roots grade 9s that tends to catch a lot of grade 9 students out. So I'm going to go over that as well. But let's start at the very beginning. You guys can quickly write a small heading down. If you guys have specific questions, you're more than welcome to ask. I would love to hear if there's anything that you guys want to know a little bit more about. I'll do my best to keep an eye open for messages in the comment box. Please remember that you're more than welcome to send your messages through, and as soon as I see them, I will respond to them. Okay, so let's start by looking at some of the more simple examples. Let's say we have 3 is equal to x over 4 minus 3. Remember, we always want to focus on trying to find the value of the variable. So in this case, you can go ahead and practice identifying it. We know that we are looking for the value of x over here, and we have a few simple components in this equation. So what I'm going to want to do is gather all of the variables on one side and the constants on the other. I already have a constant on the left-hand side over here, so I'm going to want to move this minus 3 over to the left-hand side of the equation. When I move a minus 3 over to the other side, it becomes a plus 3. So on the left-hand side, we're going to have 3 plus 3 is equal to x over 4. We know that 3 plus 3 is equal to 6. And we can leave the right-hand side of the equation as is. Now, I'm trying to isolate my x over here, but what's making that a little bit tricky is the fact that it's being divided by 4. So to reverse the effect of dividing by 4, I can multiply by 4 on both sides of the equation, right? And on the right-hand side, I've written multiplying by 4 as a fraction of 4 over 1, just so that it's a little bit more obvious that we are cross-canceling. On the left-hand side, 6 times 4 is going to give us 24. And on the right-hand side, we can see that our 4's are going to cancel, leaving us with x times 1, or 1x, which is just written as x. Now, this is not compulsory, but it is sort of an unspoken standard that we like to have our variable on the left-hand side and the value that it's equal to on the right. So in an example like this, guys, you are allowed to switch the sides of the equation around without changing any symbols, right? And so in this case, we see that x has a value of 24. You guys can obviously go and substitute 24 into x's place in the original equation, and you will be able to see that the left-hand side should be equal to the right-hand side. All right. So you just underline your answer and make sure that everything is written in a relatively logical format. I'm going to move on to number 2. If you guys have questions, you need to please ask. Now, what happens if we have fractions involved, right? This is again where students get a little bit nervous. If I have something like x plus 5 being divided by 3, and this is all equal to 12, what is the process that I want to follow? Now, remember, you need to make sure that you are comfortable with finding the current obstacle that you're facing, right? So when I look at x plus 5 over 3 is equal to 12, we know that we're solving for the value of x. And what's making everything a little frustrating right now is this whole fraction, right? There's nothing I can move over to the left or right-hand side that's going to benefit me. But if I can get rid of this fraction, things will get a little bit easier. So that's what I'm going to start with. If I have this entire fraction being divided by 3, I'm going to want to multiply by 3, right, to reverse its effects. Now, I'm going to write everything out in this example, but you do not have to do this in a test or an exam, right? We can multiply by 3 over 1, but whatever we do to one side of the equation, we must also do to the right-hand side. Right? So we multiply every component of the equation by 3. On the left-hand side, we will see that the 3's cancel out, and we are left with this whole x plus 5 multiplied by 1. Right? Now, we don't need to write out the multiplied by 1 because anything multiplied by 1 is itself. So on the left-hand side, we have x plus 5. While on the right-hand side, we have 36. Now, we can see that we are left in a position where we can deal with a simple equation, a linear equation, and we want to move this 5 over to the other side of the equation so that we get x on its own. When I do that, I leave x on the left of the equation, and my plus 5 becomes a minus 5. Remember, when dealing with terms that are added or subtracted, when you move it over the equal sign, it will change its sign. So 36 minus 5 is going to give us 31. So the answer to equation number 2 is going to be 31. I hope that these are all making sense so far, grade 9s. If you have questions, please just shout. I'll do my best to answer any questions that you have. Okay, now in example number 2, I just want to point out that although I said we generally want to try and deal with adding and subtracting first and then multiplying and dividing, you can see that in example number 2, there was nothing to move over the equal sign yet, grade 9s. We first had to get rid of this fraction. So example number 2 is just an example of one of those equations that sometimes necessitates that you do your multiplicative inverses before your additive inverses. Okay, let's take a look at another example. A half multiplied by x minus 2 is equal to 5. How do we go about solving this sort of equation? Now remember, please, grade 9s, if I have any fraction that is multiplied by a value like this, a half times x, for example, this x belongs to the denominator should you wish to move it. So a half times x is the same as x over 2, right? This is being multiplied to the numerator over here. So just be aware of this kind of manipulation because it can really help you in certain questions. So if we do this, over here we can see that we want to get x on its own, and now we can move some things around, right? This negative 2 can go over to the other side of the equation. So on the left, we're going to leave our half x as is. And this is going to be equal to 5 plus 2. So we have a half times x is equal to 7. Now, in this sort of situation, a lot of students tend to get thrown off because they are not familiar with this kind of manipulation over here. If I have a half times x is equal to 7, right? I am multiplying x by a half. That's what a half x means. So in this case, what would we want to do? Here we would want to divide by a half in both cases, right? Divide by a half on the left and on the right. And this is where students get a little bit confused because they see 7 over a half and it looks like a 3-piece fraction, and everyone gets a little bit thrown off. On the left-hand side, it's easy to see that the halves are going to cancel, right? Leaving us with just an x. But on the right, we have 7 over a half. So we can think of this as 7 over 1, or just 7 divided by a half. Right? The value 7 can be written as 7 over 1, and it's being divided by a half. Now, if you have not brushed up on your division of fractions, we can use tip and times to our advantage. You leave the first fraction as is, you tip the second fraction, and you multiply. When we do this, 7 times 2 gives us a value of 14. But in a test or an exam, a lot of students get caught out by this idea of dividing by a fraction. So what is the alternative to that? It's got to do with the manipulation that I've written down on the right-hand side. We can view it as this left-hand approach, or we can view a half x as x over 2 is equal to 5 plus 2. Right? X over 2 will be equal to 7. Now, just by... Okay, sorry guys, just a second. A few people are saying that you cannot see what I'm writing. I have no idea why it's doing that. Just give me a second. Sorry, guys. Sorry, grade 9s. I don't know why it stopped showing what I was writing. I apologize for that. Just give me a second to fix that very quickly. Sometimes technology has a mind of its own. All right, I hope that you guys are now able to see my screen again. I'm just going to give it a second to reflect on your side. Okay, you guys should be able to see my screens again, or my screen again, right? I do apologize for that. Sorry, guys. Right, so what I was essentially saying, I'll track back just a few seconds. On the left-hand side over here, if we have a half multiplied by x, the way we get rid of that half that is being multiplied is by dividing, right? So I would divide by a half on both sides of my equation. But that leaves me in a position where I have 7 divided by a half, right? And if you're not comfortable with dividing fractions, this might give you a little bit of a hard time. So we can still see how we solve this. We divide two fractions and use the tip and times method to get a value for x that is equal to 14. But like I was saying earlier, a half multiplied by x is the same as x over 2, right? Halving something is the same as multiplying by a half, right? Dividing by 2 and multiplying by a half are the same thing. So on the right-hand side over here, I'm doing exactly the same example, but just showing you a different approach that you can take. So if I now have x divided by 2 is equal to 7, how do I get rid of the effect of the 2 that is being that is dividing my x? I would have to multiply by 2, right? And I'll write this out again. You wouldn't necessarily do this in an exam setting, but we would multiply by 2. But what we do to one side of the equation, we must also do to the right-hand side. On the left-hand side, the 2's will cancel, leaving me with an x. And on the right-hand side, 7 times 2 gives me 14. So it doesn't matter which way I go about it, grade 9s, I still get the same answer. But depending on how you want to interpret certain values, you'll see on the left-hand side, we had to divide, right? This step required division, whereas on the right-hand side, we had to multiply. So the way you choose to interpret a fraction is going to have an impact on the way that you solve it. Okay, I hope that that makes some sense, guys. I'm going to give you a second to quickly copy this down if you'd like to. Just remember that this is the rule that I've used. Sorry, listen to me. This is the rule that I've used to come up with the 2 different variations of solving the same question. So please take note of that. All right. Now, because there is only a total of 20 minutes left of today's lesson, I do want to quickly touch on exponential equations as well. All right. I'll give you a second to quickly copy. Then we're going to take a look at exponential equations. Now, grade 9s, please remember, guys, there are a lot of different examples or variations of equations that you guys can be given in a test or an exam, right? I'm not able to go through all of them. I see that it stopped. I'm not sure. Sorry, guys. Technology is giving me a little bit of a hassle today. I hope that you can still see everything on your side. There are so many different variations of equations, guys, that I cannot go through all of them, right? But it does mean that you guys are going to have to spend some time going through equations on your own. You need to practice all kinds of variations, all right? You have got to put in a lot of practice. A 1 hour session, as much as we wish that it could solve all of our misunderstandings, generally speaking, the best way to improve your understanding is really by practicing. Okay. So I'm going to move on. If you need me to come back up to this just now, I will. But I want us to quickly discuss exponential equations, guys, because these are also examples of equations, right? But now they are using the laws of exponents that we discussed at the beginning of the year. So let's say, for example, we had 2x is equal to the power of 16. If we had addition and subtraction and multiplication and division, we would want to deal with all of those inverses first. But as we move forward, we find that they are going to be exponential equations too. Now, this is an example of an exponential equation where we don't have anything else to worry about other than the exponential part itself. So when I'm given something like this, 2 to the power of x is equal to 16, grade 9s, the goal whenever I work with an exponential equation is to manipulate both sides to have the same base. Okay. You can make a note about that, but this is your golden rule. You want to manipulate both sides to have the same base. Right? So on the left-hand side, I have 2 to the power of x. There is nothing I can do to change the base of 2 over here. But on the right-hand side, I need to find a way to convert 16 into an exponential term that has a base of 2. Now, 16 is the same as 2 to the power of 4 because it's equal to 2 times 2 times 2 times 2, right? So you must make sure you are familiar with your basic exponents. And when we have a case in which we have one term on either side of our equation that has the same base, you may drop the bases and make a linear equation out of the exponents. So here it's as simple as writing down x has a value of 4. Right? This is a very simple example, but the goal is to show you guys that we have to learn how to manipulate the bases so that they are the same on either side. What happens if I'm given a more compound exponent? 5 to the power of x minus 1 is equal to 125, for example. How do I deal with this now? Well, it doesn't matter what my exponent reads, but I must pay close attention to the base of my exponent, right? So on the left-hand side of my equation, I have a base of 5. Now, there is nothing I can do to change that base. Okay? So on the left-hand side, unfortunately, 5 to the power of x minus 1 needs to remain the same. But on the right-hand side, we can manipulate 125 to have a base of 3. 5 to the power of 3 is equal to 125 because it's the same as 5 being multiplied by itself 3 times over, right? So you really do have to familiarize yourself with the basic exponents that we use, squares and cubes most commonly. So now that I have the same base on both sides, only at this point, grade 9s, am I allowed to drop my bases and make a linear equation out of the exponents. So x minus 1 is going to be equal to 3. And here we can see that we just want to move this 1 over to the other side so that we can get x on its own. We're going to have x being equal to 3 plus 1, because when we move a negative value over the equal sign, it must become positive. Okay. This is really, really important, guys. When it comes to dealing with exponents, your goal is always going to be to manipulate the bases, but only once we have one term on either side of the equation. Okay? Now, this does beg the question if we can combine the first section of work that we learned with the second section of work, that we've discussed. So I'm going to do 2 more examples, and if you guys have any questions, you need to please let me know. Okay. Let's say I, for example, had 100 to the power of 2x. Or actually, no, sorry. No, let's just say I had 10 to the power of 2x is equal to 10,000. In this previous example over here, we needed to use our additive inverses, right, to be able to solve the final linear equation. Now, if we look at example number 6, things change ever so slightly. Again, our goal is to make sure that we have the same base on both sides of the equation. So on the left-hand side, guys, 10 cannot be written as another exponent, right? So we're going to leave 10 as is to the power of 2x. But 10,000 can definitely be manipulated, right? We can break this down into 10 times 10 times 10 times 10. Okay, which is the same as 10 to the power of 4. Now again, when you have an identical base on the left and right hand side of an equation, you may drop the bases and make the exponents equal to one another. And in this kind of example, you can see that in order for us to get x on its own, we would need to divide by 2 on both sides, grade 9s. Divide by 2 on the left and on the right. On the left, the 2's are going to cancel out, leaving us with just x. And on the right, 4 divided by 2 gives us 2. Okay, and finally, number 7. If I had something like 4 to the power of x is equal to 32. How would I solve this kind of equation, guys? Again, being able to solve exponential equations is going to rely relatively heavily on your understanding of exponential the exponential laws, right, that we discussed earlier on this year. So looking at 4 to the power of x is equal to 32, what is the problem that we run into? Well, we can leave 4 to the power of x as is, but what do we need to do with the 32 now? Because let's think about our exponents of 4. 4 to the power of 1, 4 squared, 4 cubed. What are these all equal to? 4 to the power of 1 is 4. 4 to the power of 2 is 16, and 4 to the power of 3 is 64. So what this tells us is that there's no way for us to express 32 as 4 to the power of something. We cannot do that because 32 cannot be expressed as 4 to some or other power. So now the problem is we can't use the base that we have on the left-hand side over here, on the right-hand side. So what do we need to do? Well, we always need to pay attention in this sort of situation to the base then back on the left-hand side. 4, the number 4 can be written as 2 squared, right? What that means for us is that this left-hand side of the equation can be 2 squared to the power of x, right? Because 4 and 2 squared are exactly the same thing. It's just a manipulation. And the advantage of us using 2 as our base, grade 9s, is that 32 can be expressed as a power to a base of 32, right? If we use 2 squared, 2 cubed, 2 to the power of 4, and 2 to the power of 5. 2 to the power of 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the power of 4 is 16. And over here we have our golden ticket. 32 can be expressed as 2 to the power of 5. And now we have like bases on either side, right? Which is the golden rule that we want to apply when working with exponential equations. So we have one extra step to deal with here, and it's got to do with the fourth exponential law. When we have a power raised to a higher power, grade 9s, we multiply the powers. So 2 times x is simply 2x. And then we have 2 to the power of 5 on the right-hand side. Now that our bases are the same, we may cancel these bases or drop the bases, and 2x is equal to 5. And now, in order to isolate x or get x on its own, we want to divide by 2 on both sides. On the left-hand side, our 2's are going to cancel, leaving us with just x, and 5 over 2 is the unknown value that we were looking for. Okay, so be aware that you sometimes do have to put in a little bit of extra thinking and manipulate not just one side of the equation, but both. All right, I hope that that makes sense, guys. And there's one last example I want to go through for today, and then we will wrap up. Example number 8. It seems like it's one of the simplest examples of all, but it still catches students to this day. And teachers absolutely love it. This is not necessarily an example of an exponential equation, but we do have to worry about exponents and roots. So on the left-hand side, we have x squared, and on the right-hand side, we have 16. Now, there's no adding that can be done, no subtracting, no multiplying, and no dividing that can be done either, right? Our goal in this question is to get x on its own. And we know that the power of 2, the squared symbol, is what's in our way, right? What is the inverse of squaring, grade 9s? It is square rooting. So if I want to get rid of the effect of the square symbol on the left-hand side, I need to square root the x squared. But what I do to one side of the equation, I must do to the other. Okay? On the left-hand side, again, the root sign and the square symbol are going to cancel, leaving us with just x. Now, what is the square root of 16, grade 9s? A lot of you are just going to tell me that it's the value 4, and you've got half of the answer. Right? 4 squared definitely is equal to 4 times 4, which gives us 16. But if I square negative 4, what does that mean? I have negative 4 times negative 4, which still gives me a positive answer. So whenever I square root a positive value in my last step of an equation, you need to write down a plus or minus symbol in front of it. The answer is plus or minus 4, because both positive and negative 4 can be put into x's place to make this equation true. All right. Please, please, please beware of this example. Teachers absolutely love it. All right. So grade 9s, those are the fundamentals of how we want to solve equations. All right. The reasoning for the plus and minus is over here on the right if you're looking for it. So what are the 5 tools that we can use whenever it comes to solving an equation? Let's wrap up. Number 1, we can use our additive inverses, right? In other words, we can move values that are being added or subtracted around the equation by changing their sign as we move them over the equal sign. We can deal with most fractions by applying multiplicative inverses, right? When we have values being multiplied to our variable or values that are dividing our variable, we use multiplicative inverses. We can also use exponent bases to help us for exponential equations, right? We know that if we can get the exponent bases the same, we are allowed to drop the bases and make a linear equation out of the exponents. What else can we use to our advantage? We can use exponent root inverses, which we just saw now in the last example. To get rid of a square root, to get rid of a square, we use a square root. To get rid of a cube, we use a cube root. If we have something to the power of 4, theoretically we can use a 4th root, right? Not that they're super common, but we can use those to our advantage, and the reciprocal. And finally, something we just missed out on today, our last step is factorizing. Factorizing can be really helpful because it's a way for us to manipulate what we see, right? So it's actually a matter of fact that factorizing and simplifying belong together. So I know that it might seem quite simple, guys, and that the examples we've been through today aren't the hardest ones that we have seen. But like I said at the beginning of the lesson, it's more about me trying to show you guys that we have a few different tools at our disposal when it comes to solving, right? If I have an equation where I don't have any adding or subtracting or multiplying or dividing, maybe I want to look at using exponents or root signs, right? Maybe if I have no adding, subtracting, multiplying, dividing, roots, or exponents, that I first need to go about factorizing something so that I can cancel brackets, right? Or find ways to further expand the information that I have. So when we're solving an equation, I think it's useful to have a checklist like this, especially when you're looking at a question in a test and you're not really sure of what the next step should be. Quickly write this list down, right? Take a look at it and go through each one. Ask yourself, what can I achieve next? What is the next step that I can take? Okay. So I really do hope that you guys have learned some valuable information from today's lesson. If you learned something from the examples, that's awesome. But please remember, guys, when it comes to algebra, a lot of the time we have to manipulate, right? It's a game of changing the way that things look. I know that not that many people think of maths as being something that's creative, but in reality, the best math students are the ones that can see something written out in many different formats. Just like I mentioned earlier, for example, a half times x is the same as x over 2, right? And again, this just comes back to manipulation. We can even see this as 1 over 2x to the power of negative 1. Okay, so guys, I really want you to understand that maths is a game of trying to reshape and redesign whatever you're looking at so that you can move on with the question. All right. But guys, unfortunately, we are out of time for today. I do wish that I could spend a little bit more time teaching you guys about this, and maybe we will have another lesson in the future about these algebraic equations. But what I really want you to take away from today is that I cannot go through every different example of an algebraic equation with you, right? We can have one equation that's written out 5 different ways. So instead of going through example after example after example with you guys, I hope that maybe rather showing you an approach that you can take and a checklist that you can use to help you solve equations will be more useful, or has been more useful. All right. So guys, that's it for today. Please remember that you can go and look at iRainbow. There are quizzes on everything to do with algebraic equations, from basic equations to additive and multiplicative inverses to exponential equations and more. Okay, please use that resource. It's there for a reason. Go and use it to your advantage, even if it's just to test your understanding so that you can see how much more you need to study. Okay, so grade 9s, that's it for today, guys. Please remember that we will have another lesson again next week, Tuesday in the evening from 5:30 to 6:30. I hope that I'll see you guys then. If you have any questions, you're more than welcome to type them into the comment box quickly. I'll sit and watch out for them. But for those of you that are happy and understand everything that I've explained, you are more than welcome to leave. Okay, today's lesson is done, guys. Just keep in mind, the recording for today's lesson is now available on Facebook and on YouTube. Okay. And the same will be true for every lesson held from here on out. Okay. So if you need to come back and watch the videos, you can, and you can even choose which platform you do it on. All right. Thank you so much, grade nines. I hope you guys have a fantastic evening further and an even better Wednesday tomorrow. All right. I'll speak to you all again next week, guys. If you have any questions, I'm sticking around for a few minutes. Otherwise, you're more than welcome to leave. All right, guys, I haven't seen any questions. If you do think of something that you'd like to ask next week during our lesson, please just write it down so that you don't forget. And just remember to ask me at the beginning of next week's session. All right. Thank you so much, grade nines. I'll speak to you all next week.